Okay, now we continue about 6.2, which is Centripetal Force. At the end of this subtopic, students should be able to define Centripetal Acceleration and then solve problem related to Centripetal Force for uniform circular motion cases, which is conical pendulum, horizontal circular motion, and vertical circular motion. Exclude blanket curve. So, what is centripetal force? So, before we learn about the centripetal force, we learn about the centripetal or radial acceleration, AC or AR. Biasanya, commonly kita guna centripetal acceleration lah. Tetapi dia membawa maksud juga radial acceleration. Sama ada AC ataupun AR. Tapi commonly biasanya kita akan pakai AC lah. Okay, so what is the centripetal acceleration? AC is an acceleration of an object moving in circular paths whose direction is toward the center of the circular path and whose magnitude is equal to the square of the speed divided by the radius. Keyword dia di sini adalah toward the center of the circular path and magnitude is equal to the square of the speed divided by the radius. Itu adalah 2 point of the centripetal acceleration. It's always toward the center and AC is equal to V square over R. This is the equation of centripetal acceleration. Okay, from the equation of V just now, V equal to R omega. So, from the equation of V square over R, and we combine with V equal to R omega. So, another equation we can use is AC equal to R omega square or equal to V omega. Biasanya commonly kita pakai yang ni lah. Tapi dia masih ada beberapa certain cases kita boleh pakai R omega square ataupun V omega. Okay, where AC is the centripetal acceleration, V is a linear or tangential velocity, and R is a radius of circular path. Omega is angular velocity or angular frequency. Okay, so the direction of the centripetal or radial acceleration is always directed toward the center of the circle and perpendicular to the linear tangential velocity. Point yang pertama tadi kita dah belajar, dia always directed toward the center of the circle. Okay, next point adalah dia mesti perpendicular to the linear or tangential velocity. Okay, kalau kita tengok motion and object, okay, this is a motion and object. Okay, dia bergerak dalam circular path. Okay, so direction of AC is always directed to the center, to the center of the circle. So first of all, kita tengok circular path. So determine dulu center dia. So center mesti duduk di tengah-tengah lah. Okay, so AC ni dia always directed to the center and always perpendicular to the V. Okay, itu adalah point yang kedua untuk centripetal acceleration. Okay, in a uniform circular motion, the magnitude of the centripetal acceleration is always constant, but its direction continuously changes as the object move around the circular path. Macam kita dah belajar chapter 2, kita belajar mengenai bila changing velocity adalah constant acceleration. So, sama macam circular motion ni, centripetal acceleration dia adalah constant, tapi direction dia sentiasa berubah depend kepada position. Macam kita tengok kalau position at the bottom, so direction of AC dia akan toward the center lah. So, bila toward the center, kalau duduk kat bottom, toward the center dia adalah upward. Okay, kalau dia duduk dekat at the top, so toward the center dia adalah downward. So dia akan keep changing lah direction of the centripetal S ratio. Okay, next one, we go for the centripetal force. What is the centripetal force? It's a net force acting on a body causing it to move in a circular path of magnitude. So kita ada centripetal force. Macam kita dah belajar sebelum ni, kita belajar total force ataupun net force kan. Okay, so dalam circular motion kita ada net force dia juga, ataupun kita ada total force, which is net force or total force dia adalah equal to centripetal force. So sama macam konsep dalam chapter 4 yang kita belajar total F equal to MA. Ini adalah chapter 4. Okay, so dalam chapter circular motion ni, so total F kita is equal to FC. So equal to MA juga. Tapi A dalam circular motion dia adalah refer kepada centripetal S ratio. So dia akan jadi MAC lah. And just now AC is equal to V square over R. So total force kita akan equal to MV square over R. Dia kita boleh pakai analogi daripada chapter 4 lah. Sebenarnya konsep dia lebih kurang. Cuma dalam chapter 6 ni kita berkaitan motion of an object ataupun a body bergerak dalam bulatan. Okay, so equation dia pun akan berubah sedikit lah. Sebab depend kepada AC kita tadi, dia adalah V square over R. Ataupun kita boleh tulis MR omega square ataupun MV omega. Okay, so centripetal force dia sama macam centripetal S ratio, always directed toward the center of the circular parts. Dia sama macam direction of AC. Dia always directed toward the center of the circular parts. So kalau ini pergerakan an object, dia bergerak dari sini, moving here at this position. So kalau at this position, the V is perpendicular to the circular parts, and the AC is toward the center, and FC also toward the center. At any position, dia akan pakai konsep ni. V is perpendicular to the circular parts. Okay, so AC is toward the center and the FC is toward the center. So maksudnya di sini FC the same direction with AC. Okay, so if the centripetal force suddenly stop to act on a body in the circular motion, the body flies off in a straight line with the constant tangential linear motion lah. Okay, constant tangential or linear. So maksudnya di sini, kalau objek ni dia bergerak dalam membulat kan, gerakan membulat. Okay, and suddenly centripetal force stops. Tak ada dah centripetal force. So dia bergerak tu nanti finally dia akan go kepada kinematic of linear motion. Dia akan bergerak secara linear lah, linearly. Okay, and in uniform circular motion, the net force of the system is equal to centripetal force. Macam kita dah explain tadi. Kita belajar dalam chapter 4, total F equal to MA. So dalam chapter circular motion, total F is equal to FC, which is equal to MAC. Okay, and then the work done by the centripetal force is 0. The work done by centripetal force is 0, but the kinetic energy, kinetic energy of the body is not 0. Work done is 0, but the kinetic energy of the body is not 0, and is given by K equal to half mv square, or V is equal to R omega, Another equation we can use is half mr square omega square.